is a device consisting of a metal knob connected by a metal stem to two thin, lightweight pieces of metal foil called leaves.
So you can see here the leaves. You can see here the two leaves, right? And whenever I'm touching, so the leaves are coming down. And whenever I'm giving force, so I start, like from this machine, fly stick, or even you are rubbing, right? That too, one woolen cloth and the perspex rod, or even the glass rod, or even the plastic rod. And if you have to touch it here, you can see that both of these two are also going out, right? So actually that is the electroscope, and that is the key vocabulary for today. Okay, now the next one, next segment, charging by conduction.
Charging by conduction. Charging a neutral body by touching it with a...
Okay, so charging by conduction also I showed you in your class. Already we have done it. The one which we are doing here, right? Through the electroscope. That means if you like to bring the positive one, so both of these two are closer together. And if you like to use the negative one, so they will just get out. Still we are in one dimension. Because the light charges tickle each other. Unlike charges attract each other. You learn in your middle school. But these are the basic ones to start before starting with the Coulomb's law. Okay. I think now we can start the Coulomb's law. Okay, I'm just skipping this one. Yes. Now we are at the topic, Coulomb's law. Please everybody silent.
In 1785, French physicist Charles Coulomb solved the problem of varying the quantity of charge in a controlled way. This is the type of apparatus used by Coulomb. An insulating rod with small conducting spheres A and A dash at each end was suspended by a thin wire. A similar sphere B was placed in contact with sphere A. When they were touched with a charged object, the charge spreads evenly over the two spheres. Because they were the same size, they received equal amounts of charge. The symbol for charge is Q. Therefore, the amount of charge on the spheres can be represented by the notation QA and QB. Coulomb found how the force between the two charged spheres depended on the distance. First, he carefully measured the amount of force needed to twist the suspending wire through a given angle. He then placed equal charges on spheres A and B, and varied the distance R between them. The force moved A, which twisted the suspending wire. By measuring the deflection of A, Coulomb could calculate the force of repulsion. He showed that the force, F, varied inversely with the square of the distance between the centers of the spheres. To investigate the...
Now you can see that this machine, the round one, here you can see the red color, that is actually the QA. Everybody were having it in your table, right? So the QA you can see, here the red one is represented over here the QA. And whenever we are giving them the charge here, then how that is changing according to the distance. So you can find, you can see the Coulomb's law here, so how it is working. Okay?
The way in which the force depended on the amount of charge, Coulomb had to change the charges on the spheres in a measured way. He first charged spheres A and B equally, as before. Then he selected an uncharged sphere, C, of the same size as sphere B. When C was placed in contact with B, the spheres shared the charge that had been on B alone.
So this is charging by induction. I told you 3 minutes back. Charging by induction. Like I am touching here, and from here the pass that is transferring and going to here, right? So that means that is charging by induction. You rub something few minutes back. That is charging by rubbing. Okay? And charging by conduction. Something is already positive, like this one is already plus. And whenever I kept this one, at the beginning I touched this one, this also became plus. So by touching, it is transferring charge. That is charging
same size, B then had only half of its original charge.
Original charge.
Therefore, the charge on B was only one half the charge on A.
Okay, I can just
After Coulomb magnitude of the force between charge Q.
So let me explain the other part. Okay. So maybe you understand half. Just go to make another half to understand. So before that, please write the Coulomb. So
Coulomb.
Coulomb's law.
The SI standard unit of charge is called the Coulomb.
Please write. The unit for charge is Coulomb. Okay, so that is not the law. The unit for charge is Coulomb. So the law which is related between two charges. Okay, and which one can make the relation between two charges force. So that law is called Coulomb's law. So Coulomb is the name of a scientist who made it. Coulomb is the name for the unit of charge, and Coulomb's law, it will indicate or it will make a relation between the
这么早把
force
作业
of
写
two
完，就回
charges.
去能打上转还是咋？
Okay.
Elementary charge.
Elementary charge.
The magnitude of the charge of an electron is called the elementary charge.
你好学屁！
Okay. Now, it's the writing part. This is Coulomb's law.
我的借有好多天了呀。
Coulomb's law, the magnitude of force.
你想就把你那大把牙收起来，
Everyone, please copy from here. Coulomb's law, the
别
magnitude
吓着人了，吓着我了没事儿。
caused by charge QB, a distance r away, can be written as follows: F equals AQA QB by r squared, where QA and QB, these two are charges, and r or b as the distance between these two charges, and f is the force which is experienced between these two charges. So here I must write it for you so that you can understand. F is force between two charges, and the unit for force, that is meter, and after that D is perpendicular distance between two charges, QA and for which QA and QB are the charges in coulombs, and the gauge of oxygen. Yes, Jason.
The QA and QB represent the charge of people.
Two charges. Like I showed